where AI is going to affect the mankind. So, thought probably I'll take you through how the battles are won with AI, and there's a topic everywhere, how the Iran war AI was, Anthropic was used and Claude was used there, and how Israel was using the AI in their, the war domain. So, when we talk about so much about implementation of AI, when it was used, considering that it is doing the job what it's supposed to, and when it is not, and the results are catastrophic then. Next slide, please. So I'll take you through how the AI is used in the battlefield and modern warfare. So effectively, when we talk about the entire battle, we have been proud in the recent past what was the success of Sindoor. So you look at the Sindoor, the best thing happened in Sindoor was India's military turning point. How did it happen? It's planned with precision and executed under real-time command. It destroyed the terror infrastructure. That's the last phase of the last part of the sentence, without triggering a full-scale war. That is the beauty of Sindoor. How did that happen? Enemy drones retaliation failed, and its navy stayed docked. You have the visuals to say that what happened there. And its airspace stayed contested. Behind all these things, there are 5 game changers. If you look at them, the first one is S-400. It shielded the skies. And that's why we get the control over the entire airspace. Then we had completely indigenous solution, BrahMos, where we have a great role to play. Some of our systems flew on the system. It struck with the speed and certainty. That is the beauty of this. Specifically, this particular airborne platform is one of the unique, even rated much, well talked about there globally, the precision with which it strikes. The drones hunted targets deep inside. It's not been hit only on the territory, it went to the deep inside for create the hostile territory. This is another game changer, the Rafale. It has delivered the enemies, completely destroyed the enemy radars and deceived the enemy radars. There's one thing what we call as a spoofing, and the kind of a decoy. It creates the false target when it's flying. And that's the way the AI plays phenomenal role, how to sense the enemy targets and creates a false target, what we call as a decoy, and deceive the enemy as if the target is somewhere when your actual fighter is somewhere else. That's the way AI is extensively used there when visualizing we create what is small decoy. Sometimes it will be connected to the airborne platform. Sometimes it's a freely flown, and you create the same Doppler for the enemy radar because it's traveling with the same speed, and it senses the enemy radar and generates the radar cross section equivalent to the actual fighter. The same RCS, it deceives the enemy, and there will be many of such decoys will be kept around as if a squadron of aircrafts are coming there. It gets deceived. Meanwhile, your fighter will go and do its job and comes back. That is one of the greatest strength of Rafale system. So one of the major ones there. And the major success of entire Sindoor was the INS Vikrant just sealed the maritime. All their, typically the naval systems are docked. We were able to capture the entire, are able to see it with there. We are on alert. Though we didn't use anything, but still they were on board. All this was possible. What did it convey to us? It completely revealed a new India, confident, calibrated, and battle ready. And we could do that. And so much work went behind. Some can be, I'm not able to share much of the things. We've been part of most of the confidential things. It doesn't happen overnight. And the data was used, how the AI was implemented, not to be spelt out there. Enough is done. We knew the data collected over decades, which was extensively used. But can we never win the next war? Enemy knows our strengths and of course our weak points also. He knows what weapons you're using, and you know what, if it depends upon the carrier. And if you're using F-16, we know what weapons it can carry. If it's F-35, what weapons it can carry. You know the load it can carry, and we know the strength and the speed and the kind of the RCS it can generate. All these are known if it's going to be a commercially bought out from somebody else. So enemy knows your strength and of course the weak points. So what next? Only thing which you can, of course, every country which you can be successful there, especially in the battlefields, an integrated approach with your own solutions on the systems. That where the way we talked about the sovereignty of the entire, all the day long about the data sovereignty, then AI sovereignty, and the digital plane sovereignty, operation sovereignty. We're talking the one layer much above all these things, the hardware sovereignty. If you don't have that, then none of these systems are going to be of any purpose or use. But the hardware is the one which is going to kill the entire thing. If you look at, this is what the way integrated AI-enabled battlefield looks like. You have the airborne platforms, you have the seaborne platforms, and land-based ones. They're all connected to, this one is a representative. You see the left one. This is one of the most successful story of Gaza Strip, where even the Iran attacks there by Israel. The beauty there is the swarm. People really throw the swarm of drones. That's why we think that we've been attacking the enemy, and some of them will come and do the job. This particular, what we call as the configuration, what it does is, one of them turns into a mothership. All other drones becomes their children, and they fly, and they make the formations. They can come together, they go away, and they can change the entire course, and they can, cognitively, they connect each other there, and suddenly they can independently separate themselves. Then, they make they get the images. Some drones do the imaging, some do the security thing, some do the scanning, and they can identify which is a vehicle, which is a human being. And based on our people, you could call the people, and it doesn't stop there. Then they connect it back to the mothership. Mothership makes a decision with available data. Is the target to be fired, or target is not a hostile? Then the decision is made then and there itself, and it doesn't need human intervention. It's been attacked. I'll show what are the components there in the entire system. What are I told? It's like a story. The last slide has that. Which platforms are used to make this happen? It was used, extensively used. That's why it has been a very successful story because of the AI. This is again AI generated thing. If you look at here on the center, the unified command and control interface, you will be able to sitting there in the chamber. You might have seen the Israel war. People say that, oh, American soldiers are operating from the hotel rooms. That's exactly what it is. You can have the entire, typically, the unified command and control interface. You can visualize the entire operation, maybe I call it as a Bharat shield. You know the border, you know the terrain, you can create the complete digital twin of it there inside your the control room, and you know your assets, you know which is available, and you know the adversaries, and you can control which asset can be used to go and fire the target. Generally what happens is the forward soldiers will tell what's happening there. Based on that it goes to command. Then command will see where my weapon is there to fire. All these things can integrate it into the battlefield, and it says we know what to be hit, and we know how far it is, and what weapons are the closest range, which are there available in so many miles, and what is the capability of each weapon. One can travel at 3 max per speed, one can be 5 max, and depending on the speed with which, and the adversary is coming and what speed, and you know the way you want to intercept it, and this all can be automated. And that decision can be made. Of course, human is still in the loop. And that's the way what we call as an integrated battlefield, where the weapons and the sensors and all we don't call IoTs in the military battlefield, we call as Internet of Military Things. They're completely different, their protocols are different, and they work on a different kind of protocols, not on the conventional IoT. Of course, sometimes they use LoRa, long-range communication. Sometimes we'll have our own traditional, the backbone. Another thing which probably you might have seen in Ops Sindhu, there is continuously a kind of a denial of the information. Somebody says so something happened. Then there is to be a kind of a certification from the Indian government says that, oh, it's a fake news. It's not the true. So the wars are won by the false communication. And you call as a cyber or what are the cyber security or cyber misinformation, what are the name you give. That is one of the major thing what happening now. And you can create the fake video saying that you attacked so many places. You create a kind of image that you're not losing, you're winning. So this is another war game which predominantly happening in the recent past. It's been created heavily. And we also always counter saying that how far and how true that information. Of course, the way you have the deep fake videos there or the kind of a morphed images. So that's what we call as a cyber EMI convergence, electromagnetic interference conference. Other one is the spectrum. The entire sound of any war comes from the electromagnetic spectrum. You sense what frequencies have been operated there. Okay, what time of, how much, what kind of weapons are used, what frequencies are used, and which one you need to jam. If you look at here, so this is basically, you react to situations faster than their opponent. That is one what typically it happens. You are using your entire, depending upon the information what you have, how do you respond, not the weapons what we have. The speed with which you respond is the one which comes up there. And we have the joint all-domain command and controls, which has both kinetic platforms, integrated networking there, intelligence and surveillance, reconnaissance. Then, the most important thing is, so all-seeing interplay is the one seeing the sharing of data and information, allowing the kill chains. So when you take a decision to activate the kill chain, and the key shift is the speed and the scale, with which the amount of the data which is coming from the satellite data, drone data, and existing land data, all to be consolidated, volumes of the data of the imaging, how you process it, and which could have taken hours and days, which were done in minutes with the AI-enabled engine, and it can clearly tells that what is your target. Typically, we have our own weapons there, we have the Tejas there, and we have the Arjun tanks, and these are how you train the entire military, not literally getting onto the field. You can create all the time as the simulators using enabled solutions. So there are the 5 layers, and another 3 minutes, 5 minutes there. So there are the 5 layers, what we call as a preemptive engagement, that is called from the distance you fire, and what call as the long range free. And enemy escaped. They get to the next layer, and you have been detected. Avoid being detected. You don't want to be visible to the enemy. You have been detected. Then, even if detected, avoid being engaged. Your weapon should not be locked to their weapon. How do you not to be locked? So you try to deceive the enemy, say that you are not getting locked. Then, if engaged, you lost that level also. He locked, or the enemy locked to you. If engaged, avoid being hit. Then how do you escape being the hit? How do you maneuver yourself not being to hit? Next level, if hit, prevent the penetration. Even if been hit, ensure that the penetration is not to the deep inside. So the armors, active protection systems for most of you see the tankers, when you hit, armor opens up. If penetrated, minimize the damage through design aspects. So these are the multiple layers of the war. You implement in those lines. And to do that, what we call as a advanced battle management system, the cloud is one, the connectivity is one, then your integrated sensing is one, and the entire, you do the computing on edge so that you save the time, and we use the different kind of protocols, and we call as Internet of Military Things, and connect all of them. Each asset there in the military has its own IoT sensor. Based on that, we integrate them. And there are multiple types of jamming. We call it escort jamming. It will go along with our weaponry, and it doesn't enter into the battlefield, it stays back. Other one is standoff jamming. We stay very far off, we jam the enemy signals. Standing jamming, we go along with the entire weapons and start jamming and ensure that the mission is successful. There are multiple ways of doing it. So this is what's been done. When I say mother launcher, one of the major program what they have is Extend. The Extend AI is the one talking the Israelis, how they have been successful there. Iran war, Extend AI drones, a single operator can manage multiple drones that can scan, enter, and navigate complex environment like buildings and tunnels, where the GPS is denied. So it has lidars, it has its own cameras, it has sensors, data is already embedded inside. The autonomous operations, without GPS, using 3D mapping, they can enter and avoid the obstacles using AI. Then the next model comes to the gospel. It's called as a Hubser or the gospel to determine which target the Israeli Air Force would like to bomb. You have the entire database. All the data is collected. Now the imaging comes from the drone. Then it decides which need to be hit. Then the Legion X, a system designed to manage swarms of through the swarm intelligence. So that's the one where the mothership and the swarm of drones come into picture. Then Lavender, an AI-powered database used for the target recommendation. The target is recommended, include the facial expression of the enemy to decide is it a target or it's a kind of a false target. So the last slide. So we say, well, how are you going to look like? Typically, the future warfare will have the electronic support measures, which we'll call ESMs, Basically, it works on the intercept, identity, and locate the source of emitted signals there. You keep mapping the, what we call as the spectrum. Continuously keep looking for the signals, what they're operating. Then you have the electronic countermeasures, the actions aimed at denying or reducing the enemy's use of the electromagnetic spectrum. Then we have the electronic protective measures. You escape from that, from the EMI. If you look at the way forward, the technologies, what you're going to enable all these things is software design radios, then cognitive networks, RF-enabled cyber solutions there, advanced decoys emitters, direct energy weapons, and space-based electronic warfare, and metamaterials and signature reduction, and the quantum sensing. These are the technologies, and if you look at how they're going to interpret in terms of the war domain, it's going to be mostly transparent battlefield. It's completely AI-enabled. And there's autonomy and the mission intelligence where, though human in loop, the most of the decisions come from the autonomy of the AI implemented there in the entire battlefield. And the networked, completely, you don't work as a single weapon going there and hitting. It's a complete network solution there. Then you have the multi-domain operation concept. It's not only you win from the land, you win from the air, you win from the sea. When they're all integrated, we call as land, water, and sky. Then you do the deceptions and decoy, where AI plays a predominant role, how to deceive the enemy radars there. And we call it air-low altitude airspace, where you extensively use typically the LEOs and MEOs going to be predominantly come there, and space as the next generation warfighting domain. I think probably that's my last slide. So thank you, it's the end of the day, so it's too difficult there, then we stop at this place. Thank you.